This lesson starts with the Pythagorean Theorem, which is the a squared plus b squared equals c squared. This example wants us to actually find the value of x, which happens to be one of the legs. And just as a review, the legs are the two sides that make up, or that join together to make the right angle. Okay. This side right here, that's across the right angle, that's what we call our hypotenuse. Okay. Now, for the legs, it doesn't matter which one's A, which one's B. We'll have this, our 5 be the A, so that's going to be 5 squared plus B squared, which in this case is going to be an X. It's the value we're looking for. Okay, and then my C is the hypotenuse, which is going to be 13 squared. 5 times 5 is 25. 13 squared comes out to 169. Now I want to subtract 25 from both sides. That goes to 0. X squared is equal to 144. Excuse me. Now to get to x, we have to do what's called the square root. That's the opposite of squaring something. Opposite operation. Square root of 144 is going to be 12. Okay, so that tells me that my x is 12. Okay. Now something you may or may not remember. If you have three positive integers like this, like we do in this case, where it's 5, 12, and 13, that make this Pythagorean theorem statement true, this is what's called a Pythagorean triple. Okay, there are more than one. There's several of them, an infinite amount. But anytime you have three whole numbers that work nicely and neatly into this formula, we call it a Pythagorean triple. Another example would be the numbers 3, 4, and 5. If you plug them into this formula, it works. You'd have 3 squared plus 4 squared is equal to 5 squared. All right, this would be 9. That one would be 16, and this would be 25. 9 plus 16 is 25. So this would be another example of a Pythagorean triple. Next, I'm going to show you what's called the converse of the Pythagorean Theorem, and that's just simply us using the Pythagorean Theorem to decide if a given triangle is a right triangle. So basically, you're asking yourself, or you're asking, is a squared plus b squared, does that actually equal c squared? Okay. So here's an example. We're going to use our longest side as our c, and the other two will be our a's and b's. So we have 8 squared plus 7 squared equal to the square root of 113 squared. Okay? 8 times 8 is 64. 7 times 7 is 49. Now here's where remember that the square and the square root, they're opposite operations, so they cancel each other out. So when I square a square root, I just get whatever number's inside. So that's 113. If I add 64 and 49, that does come out to 113. These should all be question marks because we're asking, are they equal? When we get down to the bottom, yes, they are equal. So I would say, yes, this is a right triangle. All right, look at this next example. I'm going to let this one be my A, my B, and then this will be my C. And so plugging this into the formula, I'm going to have 15 squared plus 36 squared. And we want to see, is that equal to 4 square root of 95 squared? Okay, so 15 squared is going to be 225. 36 squared is 1296. Okay, now for this one, I'm going to separate it out. I'm going to do 4 squared times the square root of 95 squared. Okay. And I separated that out so that the math will be easier in my head. 4 squared is 16 times the square root of 95 squared. Let's remember that they cancel, so that's just 95. 225 plus 1296 comes out to be 1521. and 16 times 95 comes out to be 1520. So they are not equal, which means that this is not a right triangle. Now I'm going to show you what's called the Pythagorean Inequalities Theorem. And that typically says that you can take some dimensions of a triangle and decide what kind of a triangle it's going to make, if it's going to be an acute, a right, or an obtuse triangle. Okay, so in this problem, here's our dimensions. We got 4.3, 5.2, 6.1. Now in a problem like this, you always want to check if it's going to make a triangle in the first place. And remember that I can add any two sides and it's got to be greater than the third side. So basically you're asking yourself, is 4.3 plus 5.2, is that greater than 6.1? Which of course it's going to be. This would come out to be 9.5, which is greater than 6.1. Okay. You could check other combinations. You'd have to check 4.2 plus 6.1 and see if that is greater than 4.3. Obviously it's going to be, because both of these are greater than 4.3 by itself. Then you would have 4.3 plus 6.1. Is that greater than 5.2? Which again, that's going to be greater because this one by itself is greater than 5.2. So all three combinations or possibilities work. So this would in fact make a triangle, which means we can use the Pythagorean Inequalities Theorem. And what that says is that I can take the hypotenuse, or the biggest side, square it, and if it is less than a squared plus b squared, that's going to tell me that it is an acute triangle. Okay? And obviously if c squared is equal to a squared plus b squared, that tells me that it's a right triangle. Oops. Okay. And if c squared is greater than a squared plus b squared, that tells me that I have an obtuse triangle. Okay, make sure you write these down. All right, so what we want to do is we're going to use, since 6.1 is our biggest number, that's going to be our c. Remember that it doesn't matter which one's a or b as long as it's not the biggest one. So I'm just going to let this be a and this one be b. Doesn't really matter. So I'm going to ask myself, or I'm going to compare 6.1, and I want to figure out what it is if it's greater than, less than, or equal to 5.2 squared plus 4.3 squared. Okay. Using my calculator, 6.1 is 37.21. 5.2 squared comes out to be 27.04. And then 4.32 or 4.3 squared is 18.49. And if I add 18.49 and 27.04, I get that this is 45.53. And this is 37.21. And 37.21 is less than 45.3. So that tells me that my c squared is less than my a squared plus b squared. So that tells me that this is an acute triangle.